Hey there everybody. So in this video I'm going to introduce you to the law of cosines, another tool in our toolbox to find unknowns in our oblique triangles. And we are also going to introduce Heron's law, Heron's formula to find the area of an oblique triangle. This is just another tool to find area of a triangle. So remember all the rules and all the formulas and all the theorems and the laws that we already know are still in effect. These are just more ways to look at a similar problem. So here's a fun fact about triangles. If I give you any two sides of a triangle, when you add the two sides of the two smaller sides of a triangle together, that sum has to be larger than the third side. That's why I do c squared equals a squared plus b squared, by the way. So if you were to take any triangle and you were to take the short side and you were to add that to the middle side, that sum has to be bigger than the longest side. I was about to say largest. It has to be bigger than the longest side. So fun fact about triangles, just something to remember. So this triangle can exist because if you take the shorter number 3 and you add it to the middlest number 4, 3 plus 4 is 7. That's shorter than 10, and you can see what happens. My ends just fall together, leaving that 3 gap in the middle. So just fun fact, another way to check our triangles to see if they actually work. Now let's talk about the law of sines. Now this seems like it's 3 different laws, but it's not. It's one law expressed with all the sides and angles of a triangle. So when we're looking at this one, you can see that it says a squared equals b squared plus c squared minus 2 times b times c, all times the cosine of a, or times the cosine of a, that last part. So what I'm saying is some unknown side equals known side squared plus known side squared minus 2 times the first known side times the second known side times the cosine of the angle opposite of the known side. So on the left side of all of these formulas, we have a side, and on the right side, because sides are always lowercase letters, and on the right side, the uppercase letters are the angles opposite the left side. Boom. Easy peasy. So we can actually use the law of cosines to find an unknown side. Remember, these 3 formulas are saying the same thing. Just how they go together is my unknown side is going to be across from a known angle. And then we have the lengths of the other 2 sides. That's what this is saying. Alrighty, so we can use these laws, the law of cosines, to find the length of an unknown side or the measure of an unknown angle if I have all 3 sides. So let's practice. Let's find the law of cosines, side, angle, side. So let's go ahead and solve triangle ABC. Solve triangle ABC means find all the unknown parts. So I'm going to go ahead and I'm going to draw in triangle ABC. I like a visual reference. Sometimes I need it, sometimes I don't. But you know what? While we're learning it, let's set it up. So I've got my angles, my big letters, A, B, and C. Those are the vertices of the triangle, or the angles. Across from big A, we're going to have the length of side A. The length of side B is across from angle B, and the length of side C is across from angle C. Well, they told us angle A is 42.3 degrees. They told us the length of side B is 12.9, and then they said the length of side C is 15.4. Alrighty, so let's solve this triangle. Let's find all of my missing parts. Well, notice we have 2 side lengths, C and B. We have an angle, and that lets us find the side across from that angle. So I am going to use the law of cosines that says a squared equals b squared plus c squared, my 2 known side lengths, minus 2 times b times c, the 2 known side lengths again, times the cosine of the angle across from this side. Well, across from little a is big A. I can use the law of cosines when I have an angle and a side opposite it. I'll either have the angle or I'll have the side to find the angle. Let's find little a. So little a is going to be, the length of that side is going to be b squared, 12.9 squared, plus 15.4 squared, minus 2 times 12.9 times 15.4 times the cosine of 42.3 degrees. Now I am going to bang all of this into my calculator all at once. I'm not going to solve it in parts because I don't want to round, so I'm going to put it all into my calculator at once, and my calculator comes back and it says 109.6997733. There's what my calculator says. But really this goes on forever and ever and ever because of the cosine of 42.3. So I want to find a. To find a, I am going to square root both sides. So in my calculator, what I am going to hit is I am going to get the square root button, and then I am just going to square root my previous answer. So I have a Casio calculator, and my calculator has a shift key and or a second key. Mine has a shift. So I am going to hit shift square root, and I can see my square root, and then I'm going to hit shift answer so I can square root that answer. And then it comes back and it tells me a is about 10.5. Why I want to use the answer and not 109.69 round, just type in the decimal. This answer even is more accurate. A and S is this all together. So when I take the answer, it does all of that together. Boom. So I now know A is 10.5. Alright, we're not done. I still need to find angle B, and I need to find angle C. So what I am going to do is I am going to find angle C. Well, to find angle C, the formula is going to be the same formula, except instead of this being a big A, it's going to be a big C, which makes this a little c, and then the C is going to become an A. Okay, because it's the angle I don't know, which is C. So I'm going to start with the side across from it. So let's start with the side across from the angle I'm looking for. That's C squared equals my other two sides squared. There's C, so I need A and B, minus 2AB times the cosine of C. This is what I'm looking for. I am going to find the cosine of C. So, you know what? Why don't I go ahead, and I know this is going to be later in the notes, but what I'm going to do now, and I'm going to skip this. By the way, do me a favor. Let's jump ahead. Let's go ahead and solve this for the cosine of C. All right, this is what we're going to use. So if you turn your page over on the back side, you'll see it at the bottom. I want to get the cosine of C by itself. So the first thing I'm going to do is I'm going to subtract A squared and B squared. So I'm going to have C squared minus A squared minus B squared equals negative 2AB cosine C. I need to get the cosine C by itself, so I'm going to divide both sides by negative 2AB. Divide this side by negative 2AB. And that's going to leave me with C squared minus A squared minus B squared over negative 2AB equals the cosine of C. Or alternately, since I have a negative on the bottom, I can change all the signs. And I can, instead of saying this, I can say A squared plus B squared minus C squared all over 2AB equals the cosine of C. Whichever one you're comfortable with is the one that you can actually use to get cosine C by itself. Alrighty, so I just said that the cosine of C, the angle I am looking for, equals C squared minus A squared minus B squared all over negative 2AB. So let's go ahead and plug in my values. So the cosine of C is going to be 15.4 squared minus 10.5 squared minus 12.9 squared all over negative 2 times 10.5 times 12.9. I'm going to put all of that into my calculator, and that's going to tell me that the cosine of C is about 0.145812621. That's what it says in the calculator. It's less than 1, so that makes me happy. It lets me know it exists. So then we're going to take the inverse of this cosine, and we're going to find out that C, big C, the angle C, angle C is about 81.6 degrees. All right, so now we know that this one is 81.6 degrees, and we can find angle B super easy by using A plus B plus C equals 180, because all three angles in a triangle have to add up to 180. And I know we know A is 42.3. B is what I'm looking for. We just figured out that C was 81.6. We do our algebra, and we are going to find out that B is about 56 degrees. Boom, 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 boom. Actually, when I do it, I'm going to get some. The reason I did it to 56, let's see, 42.3 plus 81.6, and then I'm going to 180 minus that answer gives me 56.1. There we go. And then you may notice, there we go. So 56.1. So boom. Now, be aware, we still could have used the law of sines. When I wanted to find angle C, I could have used the law of sines. The sine of angle C over 15.4 equals the sine of 42.3 over 10.5. We could have done that. But I just wanted to get some practice in with the law of sines again, and so we can see what we are doing. Kind of cool. Alrighty, so if you've got any questions over the introduction to the law of cosines, or how to apply the law of sines to solve our missing right triangles, please let me know, and I will see you when I see you.